afternoon, guys. Welcome to tutorial number 4 of NTHS 172. In the last session, we said we are going to go through these two problems. I gave you the whole weekend to go through these two problems. Did you guys go through the problem? Maybe I had too much for you guys. But however, I'll be able to help you when it comes to this. Oh, you did do them, eh? And did you prove that this is exactly this and this is exactly that? Before I do the whole thing, the reason why I'm asking this guys is because if you are not able to solve these things, it will be very beneficial for you to talk now such that we are able to deal with the problem as early as possible. Okay? Because there's a huge possibility of writing it down. Okay. So since people said that they were able to do it, I'm just gonna go through these things very fast. Not fast, but yeah. Okay, let me just fix this. Okay, so I hope you can see this thing clearly. Hope you can see it clearly. Yes. All right, so solving the first problem. Solving number 1. Let me just say solutions. Okay. It will be very beneficial for you guys to be able to solve this. I'm being honest. Because today we're going to do differentiation of these type of questions. And then you are going to see that you don't really need to find the derivative of this. You can actually find the derivative there, then take the solutions. Yeah, because they are equal. So this can be denoted like that. And therefore, what's the whole point of writing? Finding the derivative is this in the long method. If we have told you that this and that, or they mean. Okay. So the first part is that we need to let y be equals to arc cosh of x, right? This is the first thing that we said. We said that we are going to let arc cosh to be equals to y. So after doing that, you are going to see that it is going to yield something of this nature. We're going to say that x is equals to cosh y. Yeah? This is something that we're going to get by the definition of the function multiplied by its inverse function will always be equals to the variable. Yeah. So the reason why we just have x here rather than arc cosh x is because of this particular function of yeah. So with that being said, let me remove this part right here. With that being said, let us continue with okay. And we said it is important or critical for us to understand what does cosh mean to us. Ne? What do I mean by that? The definition of cosh is just given by x is equals to e to the y. Is it plus or minus, guys? Between the two exponential functions, plus or minus?
It's plus.
It's plus. Okay, great. The reason I was asking you that is for you to understand. I told you the last time in the session that it is important for you to understand what lies between the two exponential functions. Is it a plus or a minus? And for cosh, it's always a plus. Yeah? For cosh, it's always a plus. Okay, so this will yield 2x is equals to e to the y plus e to the negative y. Né? So from here, we are just going to expand, or however, we are just going to move all of these things to one side. What I mean is we're going to have e to the y, let me say minus, because I don't want us to have minus 2x plus e to the negative y is equals to 0. Ne? I hope you are fine, guys, with this one. Ne? I hope you are well. Okay, so after this part, this is the part where we're going to introduce that e to the y. So we're going to multiply e to the y on both sides, e to the y. We're going to multiply e to the y on this side. Okay, so can you see the different colors that I've used? Oh, let me do it. Okay, so now you can see the different colors that I've used here. Okay, so now as we continue with this, we are going to see that this will give us e to the 2y minus 2x e to the y plus e to the 0, which is equals to 0. And I said to you, rather than us writing e to the 0, why don't we just write, instead of writing e to the 0, let us just write 1, right? I said let us just write 1 because it's the exact same. And then on the last example, I said to you, let z be equals to e to the y. And then after letting z to be equals to e to the y, we could safely see that this thing will give us something like z squared minus 2xz plus a 1. Yeah? Okay. Oh, this is equals to 0. Now in this case, we can use the quadratic form. We can use the quadratic. Okay. But before we do that, let me just make space. Just make space. Just do this. Okay. So before we use the quadratic formula, we have identified that this thing is a quadratic expression, and this is equals to 0, which means this is a quadratic equation, and therefore we can use the formal quadratic. And we have defined that our value of a is equals to something, our value of b is equals to something, and our value of c is also equals to something. Okay, the coefficient of z squared is 1, the coefficient of z is negative 2x, and the coefficient of c is equals to 1. That's just the constant. Okay. Now, I said to you, by definition, the quadratic formula is given by negative b plus or minus the square root of b squared minus 4ac over 2a. Yeah? Remembering that we let c equals to y. It's very important. Yeah? Okay, so let us substitute. We're going to have negative of negative 2x. And we're going to have plus or minus the square root of b squared, which is negative 2x squared minus 4. The value of a is 1, the value of c is 1. Okay, all over 2 times 1, which is 2. Okay, are you with me so far, guys?
Yes, sir.
Yes, sir.
Okay, thank you very much. Thank you. Okay, let me just move a little down. More space. Okay, after this part, we are going to see that from here, it's going to yield the following. It's going to yield the following. So we're going to have this negative and this negative give us a positive. And we're going to have plus or minus the square root of, inside the brackets here, we're going to have 4x squared. And then we're going to have minus 4 over 2.
86.
Are we fine? Are we fine, guys?
Yes, sir.
Yes, sir.
Okay. So what's going to happen is we're going to do the same thing that we did the last time. Yeah? We're going to do the same thing. We're going to just take out a 4 there. We're going to have plus or minus. But let me skip a step, guys. I want to skip this particular step. Yeah? And just say that since we know that 4 and 4 is a common factor, we take it out. What is the square root of 4? It's just going to be 2. Then have the square root of x squared minus 1 all over. Are we fine with that, right? Yeah? So after this part, we still see a common term So we're gonna have 2 and have x plus or minus the square root of x squared minus 1 all over a 2. Where, oh, you don't see the last part.
Mm.
Let's see the last part. Let me move it a little bit like this. All right. Now you can see.
Mhm.
So from here, this and that will give us 1. Yeah? This and that will give us 1. Please never mind this part. That's just light reflecting. Being amusing. With the continuation of that, let me just rub out this part.
Sir, can you please go back a bit and explain how you got 2x plus or minus 2 into this minus 1?
Yes.
Because last time I attended late, so I couldn't.
Oh, you want to understand this part?
Yes.
Okay. I just wanted to understand something which I've rubbed out. But I'd say, man. Okay, I'll just explain it just now. Okay, so what happens is, this is why I just skip that step is because okay, let me use the radar. Okay, so from, let's just try it. This step, what's gonna happen from that step is we're gonna have 2x plus or minus the square root of what is common inside the square root, it's 4. Then I'm gonna have x squared minus 1 divided by the 2. Ne? So what happens is, after having this particular thing, I'm just gonna separate these two because there is a law of sets which says that if I've got multiplication of sets, I can just simply separate a set. Ne? So I'm gonna use that idea. What's gonna happen is I'm gonna have 2x plus or minus the square root of 4 multiplied by the square root of x squared minus divided by 2. And this thing, the square root of 4 is just 2. You see that, my friend?
Yes, I do.
Thank you very much, man. Thank you very much. Do you all guys understand so far?
Yes, sir.
Yes, sir.
Okay, guys, my network is very
Yes,
terrible.
sir.
My network is very, very much terrible. Oh, my network.
No.
Okay. So with the continuation of this, okay, I'm just gonna go straight to the last step that we had. The last step that we had was z is equals to 2x, or not 2x, because we took out a
3
common.
into x.
So I've got x plus or minus the square root of x squared minus 1. Okay. Now, in this case, we do have this plus or minus. And I said to you the last time, what should we consider such that we do have a plus or a minus?
We should consider a
That
plus.
positive. We don't need negative answers.
Yeah. We said that we should consider where our y is going to be greater than 0, yeah? Greater or equals to 0. But I said to you, at the same time, if we consider that y should be like that, it means that automatically e to the y would be greater than 0. Okay, let me just say greater than 0, not greater. Let me just say greater. Okay. Now, if you have got something like that, it means that the solution e to the y, yeah? Because we said z is equals to e to the y. So let me just write it here. E to the y is equals to x plus the square root of x squared minus 1. This solution will always give us what? A positive solution, right? Which it helps us with this part of the solution. If this solution is always positive, we are going to consider it. Then the other one, the other part where is saying that e to the y is equals to x minus the square root of x squared minus 1. We have seen and we've proven it the last time that this will always give us a negative solution, right? For x is an element of real. But I don't want us to discuss the whole thing here. I just wanted to explain for those who were not here the last time why we are only taking a positive and not a negative. Yeah? Are we fine, guys? We just
Yes.
Yes, sir.
okay, so that we don't confuse other people. Let's just okay. So this is what we are going to get. And I said to you, we are not done when we get to this particular part. We are still going to take the lane on both sides. So we're going to have lane of e to the y is equals to the lane of x plus square root of x squared minus the 1, right? And then from here, we're just going to get the solution of y is equals to lane of x plus the square root of x squared minus 1. And then I said to you, what is that value of y? When we started this thing, we said let y be equals to something. We said y should be equals to what? Arc cosh, right?
Yes.
Arc cosh is equals to the lane of x plus square root of x squared minus the 1. Okay, so we have proven this thing. Proven this thing. Proven. And then you put your signature to show that you trust what you have done. All right. So any questions, guys?
Could you please repeat this example, the solution?
The solution as a whole. Okay. So let me repeat the example. Okay, so other people, are you fine with it? Yeah. Okay.
Yes, sir.
All right.
Yeah, no
So I'll
problem.
start. Okay, what's the problem, my man?
Okay, no problem. You can repeat.
Okay. I thought maybe you said you have a problem. Okay, guys, let me repeat this very quickly. But this time I'm gonna skip a lot of steps. Né? The reason why is I've got these other things I want us to do today. So I don't want us to dwell on something for a long time. But my lady, for reference, you should go back to the video that I posted on the YouTube channel and
Okay.
in a little bit better. Né? But here, I'm just gonna repeat it and move very quick. I can use the idea because it's the same idea to solve number 2. Yeah? Because it's exactly the same idea. Yeah? Let me just do that. Are you fine with that idea, my lady?
Yes.
So with number 2, guys, we've got number 2, which is arctange of x. We have to prove that arctange is equals to that particular thing. Yeah? But there is something which we should remember, guys. Yeah? The last time when I introduced hyperbolic functions, I said to you guys, hyperbolic function of tan, arctange, it is given by arctange. I mean, not arctange, but tange. Tange is given by sinh all over cosh. Okay. Let us change the whole thing. We know sinh, we know cosh, right? We know sinh, we know cosh. What I know is sinh is given by e to the x minus e to the negative x divided by 2. And then let me just multiply this by e to the x plus e to the negative x. Do you see that the 2 and the 2 will give us 1? And then the solution becomes e to the x minus e to the negative x all over e to the x plus e to the negative x. So that's how I'm going to denote tange from now. Okay? That's how I'm going to denote tange. Okay? But I'm going to do that thing that we have been doing all this time. We're gonna let minutes, guys. Okay, we're gonna let arctange of x to be equals to y. And then we're gonna introduce tange on both sides, where it's gonna give us x is equals to tange y. Ne? So now in tanh y, I'm not going to write tanh y and leave it like that. I'm just going to write it in terms of this thing that we just proved right now. So we're going to see that x is equals to e to the y minus e to the negative y all over e to the y plus e to the negative y. So now the difference with this one, guys, is that with the previous ones, sin and cos, sinh and cos, we have two only here. We just had two. So that one was very easy for us to solve, right? Now with this one, we are going to use the same logic, guys. It doesn't change anything. Just because it has something different instead of two, it doesn't change anything at all. Yeah. So let me just do this. Okay. Doesn't change anything at all. So multiply both sides. Yeah? I'm still going to multiply both sides. And if I multiply both sides, it's going to yield something like this. I'm going to have x multiplied by e to the y plus e to the negative y. This is equals to e to the y minus e to the negative y. Okay. So far, you're with me, guys. Ne? This one, I'm going with it with caution because I want you guys to follow me with this one. All right. Is there any question so far?
No.
All right. Thank you very much. Thank you. Okay. So what I'm going to do from this step is expand. Ne? Is expand. The most important part is to expand. The expansion of this, okay, let me not. The expansion of this is going to be x e to the y plus x e to the negative y. This is equals to e to the y minus e to the negative y. And we're going to do what do we know? What we know is that we are going to move either this to that side or this to that side. We always have to have a zero on one side of the equation. Yeah? We have to have a zero on one side of the equation. I will choose to bring these ones this side. Yeah? 0 is equals to, gonna have e to the y minus x e to the y. And then we're gonna have minus e to the negative y, then minus x e to the negative y. Okay, are we fine, guys? I feel like in this step, there's nothing that is going to be very hard. Okay. All right. So by definition, gonna have this simplify it, take out the common factor, have 1 minus x. You see where one minus x comes from, guys. When I take out e to the y and e to the y, I get this. Yeah? And then the next part is,
Bokam, can you please mute yourself?
Barasa.
Bokam,
okay,
can you
let
please
me
mute yourself?
let me mute everybody. Such that I save time. Let me mute everybody. Okay. So from here, we see that when you take out e to the y and e to the y, we are left with 1 minus x. Yeah? And then we're going to do the same thing, but this time we're going to take out negative e to the negative y. So we're going to take out a negative e to the negative y. Then what we are left with here is 1. And what we are left with here is plus x. Are we fine?
Yes, sir.
Okay. Thank you very much, my guy. So from here, okay, guys, I'm trying my level best to switch these colors such that you can see the difference, such that explanation. And we do the step that we have always been doing, multiplied by e to the y. We always multiply by e to the y. Okay, so somebody's saying, can I please repeat this step? Okay. Okay. So before I move, let me repeat this step very quick. Let me rub it out. Okay. So in this part, we see that we have got a common factor, right? In this part, we also do have a common factor. So what's going to happen is I'm going to simplify. Okay. Now this is into my x. Okay. Now, what we're going to do is we're going to simplify this with respect to its common factors, respectively. What I'm saying is that we're going to have 0 is equals to. Now, let's deal with this part, okay? Let us deal with the first part, this part, because it has the common factor of e to the y. So what's going to happen is, since we have discovered that this thing has got a common factor of e to the y, I take it out. Then I'm left with 1, because when I take this thing out, I'm just going to have 1. And then the minus stays minus. And then what am I left with here? If I take out e to the y, I'm left with x. Do you see that when I multiply this and that, I get this? When I multiply this and that, I get this. So I hope you understand that part. Then the second part is this one, which is not covered in gray. So I'm going to take out a common factor as well, but this time I'm going to take out a negative. So I'm going to have a negative of e to the negative y, right? And then if I take out a negative of e to the negative y, I'm going to get a 1. Here I'm going to get a plus. The reason why I'm getting a plus is because the negative times a positive is always a negative. It's very important for us to. So the negative multiplied by a positive is always a negative. Are we fine with that idea?
Yes, sir.
Okay. Okay, let me see. I see a question here in the chat. Okay. So the person is getting me. Thank you for your question. All right, so let's continue. Now we're gonna do the basic step that we know. We're gonna multiply by e to the y. We're gonna multiply by e to the y. All right. Now, oh, the time is less than 3 minutes. Okay, let us move. And then from here, guys, we know what we have to do, right? We know what we have to do. We know that this one does not get affected. This side, we're gonna get e to the 2y and have 1 minus x minus. Now, this is the part where it gets tricky because people will say e to the y. No. We actually go to get e to the 0 and have 1 plus x. And I said to you guys, we do not need to write e to the 0. Rather than writing e to the 0, we just write 1. And in this case, we're just gonna write h minus that particular one. Are we fine? Okay. All right. So we're gonna do the same idea. Let z be equals to e to the y. So we're gonna have 0 is equals to z squared 1 minus x. Okay, let me write it like this. Let me write it. 1 minus x z squared, and then because we don't have any value of b, right? We don't have any value of b, so we're gonna skip that part and have 1 plus x. Now, what's gonna happen is, okay, let me do this. I'm going to ask you to tell me what is a, what is b, and what is c. Okay, guys. So what is the value of a here?
It's 1.
1 minus x.
The value of a is 1 minus x. The coefficient of a is 1 minus x. Do you see that, my lady? I wrote this.
Oh, yeah.
Yes, the coefficient of a is the coefficient of z squared is a. So whatever that we see in front of z squared is just a. And what is the value of b?
Zero.
It's 0, right? And the value of c is just minus 1 plus x. All right. Where does this thing come from? It comes from the quadratic formula that we know: ax squared plus bx plus c. So I took this negative because here it should be plus. Yeah. So guys, this thing is gonna end now. Please use the same link to get back to the session. I'll just leave it here, and the session will end soon.